Alright, there's a video for 3VT about exercise 5 from the general revision. It says given are the functions 3/4 x minus 1.5 and also minus 1/2 x plus 3. The graph of f intersects the x-axis at point A and the y-axis at point B. And the graph of g intersects the x-axis at point P and the y-axis at point Q. And the graphs of f and g intersect at point S, and we need to calculate the area for some triangles. So first, let's make a sketch of this situation. Today I have the color red, I hope you don't mind. Here I have the y-axis, here I have the x-axis, y and x. And what you notice here is that the graph of f, the gradient is positive, but the y-intercept is negative. Sorry about that. So that means that it starts lower than the x-axis and then it goes up, so it goes there, yes. And maybe some people already saw where it will go through the x-axis, because if you do this times 2 you get 1.5, so then I already know that this value is 2. But I'll pretend like I don't know it, so we're going to calculate it in a moment. It says it intersects the x-axis at point A, so that's this, and the y-axis at point B. Now the other one, this one is the gradient is negative, but the y-intercept is positive. So this one starts higher and then goes down. So yeah, like that. Actually, I should have made it a bit more that it intersects over here. There's not really a problem. It's just a sketch. So it intersects the x-axis at point P and it intersects the y-axis at point Q. Now you probably don't really know if this one is going to intersect the x-axis more over here or more over there. It doesn't really matter. If you made a different sketch, you can still calculate everything, but then some things will be a bit weird, but yeah, we'll figure it out. We need to calculate the area of triangle OAB and then triangle APS and then another one. Okay, so O is the origin, that's this one. So what we want to know is we just want to know these numbers, because if we know those numbers, then we can finally just calculate the areas. So if you want to know the intersection point with the x-axis, then you know that the y is 0. So the first function is 3/4 x minus 1.5. Now when I say that this should be 0, then I know that 3/4 x is 1.5, so x is 2. So I already know that this value here is 2, right? So the coordinates for point A are 2.0. The coordinates for B, you have to fill in 0 in the formula, so 3/4 times 0 minus 1.5 is minus 1.5. So the coordinates for B are 0 minus 1.5. Okay? Then for G, I'll do something similar, and maybe I should have left a bit more room over here. It doesn't matter, I'll just start a bit higher. So for Gx, the formula is minus 1/2 x plus 3. So when I want to know when this is 0, then I move the 3 to the other side. So minus 1/2 x equals minus 3. So then you know that x is 6. So the coordinates for point P are 6.0. So this is 6, right? And if you want to fill in 0 in here, then you get minus 1/2 times 0 plus 3 is 3. So the coordinates for Q are 0.3. So I know that this is 3 and I know that this is minus 1.5. And then the only point that we didn't do yet is here, the intersection point, that's S. But we don't need that for question A yet, so I'll just leave it like this. So here's an overview of the sketch and also of all the coordinates of all the points that are special, like all the x-intercepts and y-intercepts. So now finally, once we've done all of this work, now we can just calculate what A is, because A is calculate the area of triangle OAB. If you take a look over here, this length is 2, this length is 1.5, so the area of triangle OAB is 1/2 times this side, which is 2, times the height, which is 1.5. So this is 1.5, that's the area. You do 1/2 times side times matching height, and that is it. Exercise B, calculate the area of triangle APS. APS. Let's see what APS is. APS is here. I already know that this length from here to there is 4, because this is 2 and this is 6. This length there is 4, right? This length is 4. So we want to know what is this height here, because then we can do 4 times that height times 1/2. So what we need to do here is we need to solve an equation. So in my paper is a huge mess. Hopefully you don't mind. I mean, this is what we needed to calculate those points. And now we're going to calculate the coordinates for point S. So we have to make an equation. I have to say one formula, so this one, equals the other. And the other is that one. And then we're going to solve that. So I'm going to do plus 1/2 here, plus 1/2 there. So you have 1/4 x. And I'm going to do plus 1.5 here and plus 1.5 there, so this is 4.5. So if you want to know what x is, I have to do a 4.5 divided by 1/4. So how many times does 1/4 fit in there? Now you can use a calculator for it if you want, but you can also just work it out. I'm going to just work it out over here, because I'm going to put the 4 in there, so that's 9/2 then. So this is 9/2 divided by, and this is 5/4. If you divide by a fraction, that's the same as multiplying with the opposite, so this fraction is going to go the other way around. And then 9 times 4 is 36, and 2 times 5 is 10, so here the answer is 3.6. So this length here, this length is 3.6. So if I want to calculate the area for triangle APS, I do a half times 4 times 3.6, which is 7.2. And that's the answer for exercise B. Alright, here you see this whole overview one more time. Okay, and then we're going to go to exercise C. We need to calculate the area of BQS. Alright, so B is over here, Q is over there, and S. Oh wait, I made a mistake. Yeah, and shall I make this whole video again? Well, I think I'll just correct my mistake. So first question for you is, what was my mistake? Did you figure it out? And otherwise, I can tell you here. Yeah, we calculated what x is here. We didn't calculate what y is there. So I still need to fill this. I need to fill that into one of those formulas to get what y is. So I'm going to fill it into this one. Here I do -1/2 times 3.6. That's -1.8. And then plus 3 is 1.2. So this length is not 3.6. That length over there. No, that length is 1.2. What is 3.6 though is this length from 0 to there, because we calculated that point S, here this point, is 3.6 and 1.2. So that means that this length is 3.6 and this length is 1.2. So I made a mistake over here. I shouldn't have written down 3.6 here. I should have written down 1.2, and then our answer will be 2.4, which makes a lot of sense because this triangle was kind of small. So it could never be 7.2, right? Why didn't I notice that? But I noticed it now, right? And we do calculate, we already knew what x is here, and we do need that for triangle BSQ, right? Because here we have this triangle here, or BQS, that one. Because this length is 4.5, and this length is 3.6. So if you want to calculate the area for triangle BQS, I have to do a half times 4.5 times 3.6. So that is 1.8 times 4.5, which is kind of annoying. I think isn't it 8.1 or so? Let me check. I'm gonna type it in. A half times 4.5 times 3.6 is 8.1. Yes. All right. And then we're gonna go to exercise D. Here it says calculate the perimeter of triangle OPQ and round off to 2 decimal places. The perimeter means when you go around it. Now OPQ is over here. OPQ. Yeah. Now OP we know because that's 6. OQ we know that's 3, and this one we have to calculate using the Pythagorean theorem. So I already know that OP is 6. I know that OQ is 3, and if you want to know what PQ is, then we're going to use the Pythagorean theorem. So 3 squared plus 6 squared. Now it does say that we have to round off to 2 decimal places, so I'm just going to calculate what this is and then round it off. This is the square root of 3 squared plus 6 squared. And then that's 6.71. So if you want to know the perimeter of triangle OPQ, we have to do 3 plus 6 plus 6.71. Now when you add all of that, you get 15.71. Alright, so a very complicated exercise. Didn't think it was this complicated when I started. I didn't think this video would last 10 minutes, but it did. So thank you for watching, and I'll see you later. Bye bye.